There we go. It's working. So many buttons to press every time.
Yes. Yes.
Hello, Pamela.
Hi, Fraser.
How's it going?
It's going. It's a Monday.
Is it a Monday? Well, you're back from some other place or something, right?
Well, I was home last week. I was in Portugal the week before that, and next week I'll be in Australia.
What? Explain that.
So iTelescope, our friends down at iTelescope, Peter Lake and Neil and company, they're dedicating a new telescope at Siding Springs Observatory, and I'm going to be there. Astropixie Amanda Bauer is going to be there, a bunch of other people, and we're going to be celebrating this new telescope coming into the network. And then I'm going to be hosted on a variety of different speaking opportunities at Siding Springs and in the city of Melbourne.
That is awesome. So how long are you going to be there for?
It's 2 weeks, and I think they've booked every moment of every day, and I will be posting that on my blog this week for any of you who are in the Melbourne area and want to come out and see what's up.
Yeah, so there's going to be opportunities for friends and fans to come and hang out and visit and see the. I'm sure you'll be busy, but there'll be lots of times to interact.
Yeah, yeah.
Oh, that's awesome. Cool. Okay. Well, if you've never done this before, you're about to experience a live episode of Astronomy Cast. And normally we don't really focus on the newsy type stuff, but you just came back from the EPC conference in Portugal. EPSC, sorry, and you've had your head jammed filled with all kinds of planetary science news, and it's Cassini's 10-year anniversary, and so there was a lot of really interesting information. And so one of those topics really sort of got you interested, and that was something you wanted to talk about this week. So,
And I wouldn't call it news. When you have 10 years of information
yeah.
culled together, it's
That's
not
news
quite
to us.
news.
That's
It's
news for us.
accumulated knowledge.
We've only just begun agreeing that the Big Bang is a theory here on Astronomy Cast. So
That's a lie.
All right, cool. So we'll do about 30 minutes to do a live episode of Astronomy Cast, and then we will stick around and answer some of your questions about space and astronomy. So you can just click on the Q&A app, which should be up in the, I don't know what it says, Fraser Cain is answering questions from the audience. You can click on that. And I know it slows down people's computers and so on. And also, we didn't have an event this week, which was a sort of breakdown in our system. Yeah, so I apologize. But some of you seem to have found your way here. In fact,
what is important is this will make it into our RSS feed, and Preston's in the process of editing together all of our past episodes that we've recorded. So that's the Dragon Con, Water Everywhere, and we had one other topic that I can't remember. Anyways.
So I'll say hi to Helga Bjorkog, Will Oni, Thomas Tranneker, Guido Bibra. Who else have we got?
Lovelies.
Michael Dobin, Nancy. Man, it's the whole team. Hugo Burnham, Nancy Graziano. So hello to the whole team. All right, are you ready to record?
Yes.
Okay.
It's even in mono. Should I press record?
Yeah, I did.
Okay.
One of us has got to record something.
Yeah, I'm recording now too. We're good.
Here we go. Astronomy Cast, episode 5. Whoops. I can't even. Am I off by a couple of hundred episodes?
Do we stop or do we let Preston?
Yeah, let's just restart.
Okay.
Let's just restart, because that's not going to help anybody.
No, but it would have greatly amused Preston. But we won't make
no bloopers in this Astronomy Cast. All right.
Okay, pressing record. Recording over that. Hi, Preston.
Hello, Preston. Astronomy Cast, episode 353, Seasons at Saturn. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
Good. So you've got a bit of an announcement. You're going to be somewhere shortly?
I am going to be down on the fine island continent of Australia from about October 2nd to October 12th, so 10 days. and I'm going to be doing a dedication talk out at Siding Springs Observatory for the new telescope that's going in, and then doing a whole variety of events in the city of Melbourne. They have packed every moment of every day in really awesome ways, and I'm hoping that some of you out there listening will have a chance to come out and hear what's up.
That is awesome. Yeah, so lots of opportunities to hang out with Pamela. If you live in the Melbourne area, this is your chance. All right, so you think we're the only place that experiences seasons? Well, think again. Anything with a tilt enjoys the changing seasons, and that includes one of the most dramatic places in the solar system, Saturn, with its rings and collection of moons. So, Pamela, you're still digesting the conference that you did in Portugal, the EPSC conference?
European Planetary Sciences Conference. Yeah, it was an amazing meeting. And it really gave me the opportunity to sit down and take in a ton of science talks, which I often, when I'm at meetings, end up bogged down in the politics of being in this business meeting, in that business meeting, in this planning session. And at EPSC this year, I was there as press, and I was like, dang it, I'm just going to take in absolutely everything I can while I'm there. And
Yeah. You know
I
what?
took
And
in
and
Saturn.
we're going to sort of rabbit hole for a second here, but I really enjoy the meetings of the astronomical societies, and this is just another one of them. And one of the reasons is because you get the sort of the full deeper news, and a lot of stuff that you learn at these meetings nobody ever gets around to making a press release for. And because the attendance of the journalists is fairly low, you just don't get, a lot of the stuff that you hear at these meetings just never makes it out to any other places. It's a very strange thing. And I quickly learned that's where the real news was in these presentations by these scientists, and I learned to just ignore the press releases and seek my own news. So and actually this is the third episode. We talked about asteroids and comets. We've talked about the presence of water and where we're all finding it, and now we're talking about some really interesting sort of updates on what's happening at Saturn.
And what is awesome about these meetings is quite often you get all of the mission teams at the meeting, both as their planning meeting and them presenting all of their science in really nice context. So in this case, everyone was there celebrating the fact that Cassini has been renewed for 4 more years, and they've completed 10 years of science.
10 years.
Yeah, isn't that kind of intimidating
Yeah,
to think
I
about?
remember being excited and reporting on Cassini arriving at Saturn.
And in those 10 years, they've got to see it going from northern solstice, so northern summer, through to equinox in 2009, and now we're slowly approaching the southern solstice. And over these years, they've seen storms change, colors change, snow and rain on Titan. And one of the things that really got me is they've had more science papers published than gigabytes of data.
Wow.
So they've published over 3,000 papers, and they're only at half a terabyte.
So the orbital period of Saturn is 29 years.
Yes.
So over the course of 10 years, they've pretty much been able to see 1/3 of Saturn's orbits. They've been able to see it go through almost half of its, seasonal fluctuations.
Variation. Yeah.
Yeah. So now with this much data, can you confirm or deny Saturn has seasons?
Saturn does indeed have seasons.
Wow. See, this is an update. When we started Astronomy Cast, nobody was sure. Does Saturn have seasons or not?
Well, I think we
do.
felt safe saying it had seasons, but I don't think anyone would have felt comfortable predicting even that the hexagon on the South Pole was going to stay in place, or that you were going to get the amazing rain and snowfall that we see on Titan. All of these changes, it's the details that we've found that are truly amazing.
Yeah, so let's talk about some of the events that happen on Saturn that have changed over the duration of while Cassini's been there and observing?
I think the most interesting one is the winter hemisphere actually changes colors. And this is because well, if you're suffering winter on Saturn, you get a double whammy. On one hand, you have the fact that when it's winter, the pole closest to you is pointed away from the sun, so the amount of light you get per square meter is reduced because the sun isn't anywhere near straight overhead. So this is the same reason we get winter and summer here on the Earth. In the summer, the sun is close to straight overhead, lots of light per square meter. In the winter, it's down closer to the horizon. The light gets spread out as it comes in at that angle. Less light, less heating, winter. Well, on Saturn, you have this extra problem called Saturn's rings. And those rings get tilted as well and act like a sun shield for whichever hemisphere is in winter. And those rings can block a lot of light. So you have this amazing cooling that goes on as you go into shadow, and what light does get through is at a lower flux. And this actually allows different chemicals to build up in the atmosphere of Saturn and not get destroyed by the UV of the sun and not get destroyed by thermal heating at the same rate that they get destroyed in the summer. And that all adds up to colors that are closer to what you see on Neptune and Uranus.
So how much of a temperature difference do you see?
I do not know that detail.
Not a specific number, but are you seeing like a really significant drop in temperatures? Because
so what you're seeing is tens of % change in the amount of incident light.
Yeah, it's kind of amazing, right? The rings are 10 meters thick, and yet you get this block that just covers that puts the shade down on the planet, and so it's a really dramatic. And you're not going to see that really anywhere else in the solar system.
And did you really mean 10 meters?
Yeah, 10 meters. I did. Saturn.
Sorry, this is the part of the show where we Google and apologize to Saturn, and some alarm goes off in my office.
Good timing.
Okay, I'm going to figure out what is doing that.
They are generally 30 feet or 10 meters thick. Says Hubble site. She can't hear me. Pamela! They're 10 meters thick. It's true.
Okay.
Oh, it's true. Oh, it's very true.
It is 10 meters?
Mm-hmm.
Okay, I thought they were thinner than that for some reason.
Thinner? Some parts of the main and other rings can be up to several kilometers thick, but the main rings are generally about 10 meters thick.
Okay. Okay. I'm allowed to get numbers wrong occasionally.
No, I know. It's very rare that I'm right. So please continue.
Okay.
Occasional win for Fraser.
Sorry, Preston. Yeah, go back to where you said the rings are 10 meters thick and continue, Fraser. Sorry.
Man, I don't even know what I was talking about. Rings are 10 meters thick, and then I said, yeah, so 10 meters thick, and then it's kind of amazing that they provide this level of shade.
And so as you end up with the tilt going from sun incident on the northern hemisphere to equatorial, in which case you get very little shadow anywhere on the surface of Saturn, things start to heat up, and that temperature gradient and that change in temperature as the heat flows from one hemisphere to the other, it generated these amazing white billowy storms that we just saw race through bands in the upper atmosphere of Saturn. And it was amazing to see thermodynamics played out at such a large scale. And with Saturn, because it is rotating so fast for such a big object, and to be entirely clear, we're not entirely sure how fast Saturn's rotating. This is one of the great stupid mysteries of the solar system. But it's rotating on order of every 10 hours. And that's pretty fast for something that Saturn's rings would just comfortably fit between Earth and Moon. And as it rotates so quickly, you get these bands that confine the weather within these different turbulent layers. And so we saw these beautiful spirally storms confined within a band billowing around as the seasons changed.
Right, but we get that situation here on Earth as we get the seasons changing. We get hurricane season. We get these
Yes.
temperature gradients, and temperatures are moving from one hemisphere to the other, and it's, creates various storms. But in this case, the change in temperature is so dramatic that you get a more dramatic, and there's no land to stop those storms. So you get a really serious set of storms that brew up.
And what's kind of cool is in the cases of looking at the moons where we do have the difference between land and lake, especially with Titan, you also see the weather change, and you also see the seasonal storms billowing up as you go across these 30-year seasons. So Titan is tilted very much the same way Saturn is. And so it was slowly going from northern summer through equinox and now approaching southern summer. And we saw a similar, well, here it's really cold, so we're seeing what we believe was snow, cases where the surface of Titan got shinier and then went from being shiny to being dry, which we think means that it snowed and then it went straight from ice sublimating out to being dry, which isn't something we see here on Earth. Then we also saw instances where it appears to have rained because the soil darkened up. You can, when you're flying over America, over the farming areas right after harvest, you can see the dark land where it's rained, and you can see the sharp delineation between someplace that rained and someplace that didn't. Well, those same dark soil delineations have now also been seen on Titan.
So, I mean, I guess when you imagine the Saturnian system with the rings, the whole system is tilted at an angle. I forget the exact amount, 20-something degrees, and then all of the moons are following that path, and so they're tilted as well. And so that's how they're going to get that same tilt as Saturn goes around the sun. And so it's kind of amazing that you would get that Titan is right at that point where the seasons would make such a big difference, that you would get the liquid methane in this case going from snowing to raining.
And it's not just methane, although that's the one that we talk about most, and it is the bulk issue. But at Titan, you have both methane and ethane at their triple point, which means that they can both, at various different places, be liquid or solid or gas. And for some reason, one of the two hemispheres of Titan has significantly more lakes than the other hemisphere. And all of the lakes on Titan added up are about the size of Lake Superior here on Earth, which is really impressive when you think about Titan is significantly tinier than the Earth's moon. So you have this little tiny world that has, when you add its lakes up, lakeage similar to the size of Lake Superior. And that lake, as near as we can tell from looking at radar returns, is a mixture of ethane and methane, although majority methane.
Did you just say lakeage?
Yes.
All right. I'm not even going to look that one up. So, right. Okay. So, are there any other impacts of the seasons then?
Well, it's not always the impacts that are so interesting as the things that refuse to go away. So with Saturn, I hinted earlier that the amazing hexagon that it has on the southern hemisphere also has a massive vortex in the very center of it that's a spherical, goes down several kilometers, vortex through the atmosphere. Those show no signs of changing with the seasons so far. We originally saw the hexagon with the Voyager missions. We're now decades later with Cassini. that hexagon isn't going away with the changing seasons. And so that just starts to lead, well, okay, why do we only have it on one hemisphere? And what's driving it? And we have models that are okay, but we can't fully get there from here yet.
So the
And
original expectation was that this hexagon would shift hemispheres based on the season, that it would wrap up when it was in the southern hemisphere and then show up in the northern hemisphere and go back and forth.
yeah,
And that's not happening.
yes,
Even
that's
when the southern hemisphere is what's directly pointed at the sun as opposed to the northern hemisphere.
yes,
Weird.
yes.
Well,
And
we added that to our whole mysteries show. So,
and then you see the things that aren't affected that much, like little tiny Enceladus that has its southern hemisphere ocean. And why is that only on the southern hemisphere that we're seeing this cryovolcanism? Why don't we see that on the northern hemisphere as well? And is that going to change? And so far, it doesn't look like it's going to. And when you look at the surface features don't indicate that there was some past great north expanse of cryovolcanism. And so there's lots of little enigmas.
and so again with Enceladus, with these tiger stripes and the cryovolcanism, I guess the expectation would be that whichever hemisphere was in the light was experiencing summer on Enceladus. That's where the volcanoes would be happening.
Well, there was actually no real anticipation that we were going to find cryovolcanism on Enceladus. That was just one of those, whoa, where did that come from moments of how is it something that tiny ends up having that much tidal heating? It just, we weren't quite prepared for that. And now we're trying to make sense of what we see, and it's kind of awesome to have puzzles.
Yeah, more data needed.
Yes, and as we move into the next few years with Cassini, it is going to plunge through one of those erupting jets and capture material out of it. And so far we've been able to have 132 close flybys of Saturn's moons, which over 10 years doesn't seem like that many, but it's orbiting. Cassini's orbiting with an orbit not too different from the moon's orbit around Earth. So you have to think on the moon goes around once a month. And so Cassini's only completed a few over 200 orbits in those 10 years. So figuring out how to do 132 close flybys across 200 orbits is some pretty amazing orbital calculating.
And the fact that
And
it's been able to sip its fuel to be able to make those little burns from time to time to get a close pass.
yeah, it's really amazing what they've pulled off with that spacecraft.
Now, I mean, this is a total distraction, but Cassini's not equipped to deal with, like, it was never meant to collect particles of ice.
Actually, it was.
Really?
Yeah, so the anticipation was that it would be collecting ring particles when it flew near the rings, it would be collecting interstellar particles, and so it actually does have particle collectors on it. So what's cool is they hadn't anticipated that they'd essentially get to be sampling a lunar sea, in this case Enceladus, because it has what appears to be a subsurface ocean, cryovolcanism. We're getting water samples from Enceladus without having to land there.
But it won't be able to detect life.
No, but it'll be able to detect molecules.
Yeah. Now, what about the
Saltiness.
rings? Do the rings have any change over the seasons?
We haven't so much seen seasonal changes to the rings as started to get an understanding of how, I don't know how to say this without punning, so I'm going to go for it. The impact of meteors hitting the rings was more than we expected. So you actually get, as a meteor or a comet, we can't identify what it was that hit the rings. As something hits the rings, it will break apart, and over the course of multiple orbits of those stuff in the rings, it generates ringlets and wave formations, and so you have the stuff that was impacting the rings changing the local dynamics of the rings for quite some time, and that's just really cool to watch.
Now, how long is Cassini going to be orbiting for? When's it done?
So we have about 4 more years, 3 more solid years of science, and then it starts this amazing set of plunging orbits until eventually it just plunges into the surface of Saturn.
So what, 2016, 2017?
I believe so. Let me get the exact year.
Yeah.
2017. So Cassini is going to keep going until 2017. And during that final year, it's going to enter a more and more elliptical orbit, going out to greater distances, and then working to plunge its way through the rings, working to get very close to the surface. And one of the frustrating things to a lot of people is it would be kind of amazing if, as it goes through these final, basically orbit 250 through death, which will be around 260 something, probably 265, could go as high as 270s. As it approaches these end-of-life orbits, it's going to eventually start potentially getting damaged more and more. So they're going to turn it to have its big antenna dish in front of it as it plunges through the rings. They're going to do everything they can to keep the spacecraft going, but as it hits 293, it's going to be getting down in its orbit to 50, 60,000 miles above the surface, and it's going to get turbulent and probably going to start tumbling. And with the high speeds and the tumbling that is potentially going to go on, it won't be able to send back radio data. So there's this huge, amazing potential for it to collect awesome data, but it can't send it back. And so that's one of those bittersweet things. Is
I'm sure they'll figure that out.
Well, it's actually a problem of time speeds. We forget how long ago they had to start building Cassini. So it has one of the first ever solid state drives, and it doesn't hold that much data. And its antenna is good, but it can't send back information that quickly. And if over 10 years we've only gotten back half a terabyte, in those few days, it can't send back all the data we might want it to collect.
It's too bad that it won't make it for a full, I guess we'll be pretty close, 14 years. I guess by the time it's done, it will almost made it halfway through Saturn's full seasonal orbit.
And that was the goal, to keep it going as long as they could, and do the last final run by the inner moons as they head towards death. So they'll go by Janus and Pan and Pandora and Ephemethus, I'm not quite sure how to say that, all as it plunges in towards death. They did everything they could to get as much science out of it as they could, but they just couldn't guarantee the spacecraft much beyond that. And with so much potential for life, we can't risk accidentally crashing Cassini onto one of these moons and potentially bringing a plague to what life might be there.
And it's also too bad that there isn't something there to pick up where Cassini left off, to watch the other half of this orbit. Because this first half, you make all of these measurements and all of these calculations, and you gather all this data, and then use that to make your models, and then you want to verify those models against reality as Saturn moves through the essentially goes through the next set of its seasons. And you'll see, we should expect Enceladus to do this. We should expect Titan to do that. We should expect the storms on Cassini or on Saturn to do this. And you're not going to have those close-up observations to actually watch these things unfold the way we get, the way we gathered them in the first place.
And this is a multifaceted problem. We brought up some of this last week, where we have issues of we don't have the money to build the new spacecraft. We're not actively in the process of building the spacecraft, and it takes years to get out that far. And even if we did have the funding and the will, we don't have the plutonium to fuel a radiothermal generator. And out at that distance, you can't use solar power very effectively.
Yeah. All right. Well, thanks, Pamela.
It's been my pleasure.
All right. Don't go anywhere. Stop our
Not
recordings.
going anywhere.
So we might have to do another recording sometime this week because Pamela's gonna be maybe traveling to.
I hit the point of confusion concerning the international dateline, so I'm not actually sure when I land relative to when we record in North America.
Okay. All right. Well, I'm just preparing people.
Yeah.
It may happen. We
and
don't know.
I'm explaining the confusion.
Yeah. So we
I'm
may
lost in time.
have to do a pre-episode later this week so that Pamela can travel. And even, if it is just after, you may be shattered and not able to find any good internet. So
Yeah.
it might be safe to do that. All right. I'm all safe. Let's look at some questions.
I am as well.
So go ahead if you've got any questions for Pamela about space and astronomy or the episode we talked about. Go ahead and put them in the Q&A app. And we'll get cracking on them. So Thomas Traniker says, so I can have all the Cassini data on my computer. So I'm assuming Thomas has a 3 terabyte hard drive ready to store all the Cassini data. Now, can you just go and just download it? Can you go to the Cassini
it's all in the planetary. Well, okay, let me rephrase that. All but the most recent is in the planetary data system, and I think that they sometimes do straight to PDS. So. Yeah, it's there. And if you go to the unmanned spaceflight forums, which are amazing, they have all sorts of people who have figured out how to use mainstream software to do image reduction of the raw images coming off of the spacecraft. I have so much respect for the folks at unmanned spaceflight.
Hugo Burnham says, irrespective of what happens to Cassini from now, it will go down as one of the most successful ever missions in history.
Yes, and it's actually also been one that's not just scientifically successful, but it's been well managed. It came out of senior review with one of the rare, this is a well managed mission. So
unlike poor Curiosity.
Yeah, they sort of got thumped. But that's a weekly space hangout kind of discussion.
Renko Prozo asks, so are the seasons on Titan related to the seasonal changes on Saturn?
Yeah.
Or do they mostly work separately?
No, it's the same tilt.
Yeah. I mean, let me see if Titan has its own tilt that would add or subtract to it, right?
Yeah, that's a good question.
It's got an eccentricity of, well, maybe that's...
eccentricity is orbital shape.
Yeah, it's got an inclination of 0.34% to Saturn's equator. So that's pretty much exactly on. So, and no axial tilt. So it is directly in lockstep with Saturn.
Yeah.
So Kevin Gill asks a question. What is the duration of Titan's axial and perihelion precession that equals the orbital period of Saturn? Could that result in the difference in leakage between Titan's hemispheres? So
I don't know if we have enough data to be able to answer that question. And more likely, the reason that you end up with all the lakes on one side instead of another is something horrific happened in Titan's past that creamed that side of Saturn, that side of Titan.
But it has a 0 axial tilt, so it has a very, very low eccentricity off of Saturn's orbit. So I think it's tidally locked. So you're not going to get precession there.
Yeah, you're right. It is tidally locked.
Yeah. Noel Ruppenthal asks, would reflected light from the rings onto the nighttime side of the hemisphere make the summer hotter too? So see what he's...
Yeah, no, it does add heating. Um, yes, but I don't know what percentage impact it has. The shadowing is a much stronger effect, but yes, that will have an effect.
Right, because it's going to be the summer hemisphere is then going to not only get what's coming directly in, but going to get some reflected radiation as well.
So it never gets completely dark, which is actually one of the awesome things with some of the images that they've done.
Yeah, that would be crazy.
We need a cloud
Um,
city. We need a cloud
Need a
city.
cloud city, yeah. Ronnie Pearson asks, given that Hubble isn't optimal for imaging planets in our solar system, is there or have there been any plans for a space-based solar system planet-moon optimized telescope, and how good could it be?
The problem that you run into is you just don't get the angular resolution you want. So you really need to just go there.
Go there.
Yeah.
Yeah, so we call that the Mars Reconnaissance Orbiter, or the Lunar Reconnaissance Orbiter, or Cassini, or New Horizons.
Messenger.
Messenger. Yeah,
Yeah.
see a theme here? Juno. Like literally,
There's
they're just, nobody is probing Uranus right now. That's really it. That's all we're missing.
You've been waiting to say that for a long
That is
amount of
all Emily
time.
Locke-DeWalla's fault. She just, that's the joke. That's the go-to joke that she makes. Guido Bieber asks, I wonder if there have been any speculation about seasons on Saturn earlier in astronomical history, like Mars canals or something, but rings had early astronomers confused enough. Yeah, I mean, when
The, Go ahead.
Galileo first saw the rings, he thought they were ears or moons or something, right?
And that very quickly got cleared up as better telescopes were built. So you had Cassini and Huygens looking at them and working to make sense of them. So yes, there was confusion, but the confusion didn't last into the modern era.
What are all the dots under the video doing? Asks Ross Anderson. We have no idea. There's some kind of applause gadget that people have
Oh,
added.
yeah.
Yeah, and people have been trying to dismantle it, and apparently we're going to try and remove it. Not well received. I think that's what this is. People are
Okay.
applauding. Yay! I love Astronomy Cast. Michael Jobin says, "Isn't the phrase Big Bang Theory just a figure of speech?"
Not anymore.
I don't know if he's making a joke
Yeah.
about it being a
I'm just
theory.
going to be confused at that one.
Yeah, the theory of the Big Bang. I think I've got everything. Let me see if there's anything new. Thomas Traneker asks, "Can CosmoQuest do anything with the Cassini data?"
We could. We haven't currently planned to do anything with it. Um, but I think that's because we have some other cool stuff coming down the pipeline.
Cool
So stay
stuff.
tuned.
Cool stuff like what?
Like, stay tuned.
Okay. I I have no idea what you're talking about. Um, Helga Bjorkug says the main rings are primarily composed of particles ranging in size from 1 centimeter to 10 meters.
And I think I was probably remembering the 1 centimeter particle size, and that's what screwed me up.
Good. Okay. All right. So,
Another episode, likely Thursday or Friday.
yeah, unless you feel really comfortable with recording from Australia.
I will sort my calendar tonight.
Okay, great. All right. Well, thanks everyone for watching. Hey, where do people find out more about Dr. Pamela Gay?
They can find me at cosmoquest.org, and I also blog on all of the darker side of life in academia at starstrider.com. But all the good stuff's at cosmoquest.org.
And Starstrider on Twitter.
Yeah, I'm Starstrider on Twitter, and there will be much tweeting from this journey.
Good. This will be great. Lots of pictures. And I'm F. Cain on Twitter. Okay, cool. Well, thanks, everyone. If I don't see you next week, Pamela, have a great trip. And we'll see you all when we see you. Weekly Space Hangout on Friday, though, so make sure you come watch that.
Yes.
We're back and running. We've done
Awesome.
3 of them so far. So, all right. See you later, everybody.
Bye.